Welcome to Excellence Second, and today we are starting a new chapter in physics, which is pressure. So first thing in physics, you need to understand that what is the pressure in solids. Okay, so we can take an example. Okay, so what is the difference between them both? The difference is that this will have less pain while it will have more pain. Why is it so? Means, okay, this is having a huge surface area while it is not having a huge surface area. Area is less, and in this figure the area is more, so we can say that this is having the less pain. Why? If the area is more, why it's the less pain? Because if there's more area, there will be less pressure, and if there's a less area, there will be much more pressure. Because of all bodies pressure, all bodies weight will come to the single point which will have more pressure at the less area. And when the area is full, the force will be distributed to each part, there will be less pressure. We can understand this by representing that pressure is inversely proportional to area. Now for example, here is the huge amount, here is the huge area. So it means that there will be more force, obviously, and there will be a lesser force. Because the area is small, there will be lesser force applying on the area. It means that the pressure is directly proportional to force. We can consider force as a weight. Remember, if the area is more and the force is applying on the area is not more because it's distributing on the area, so there will be a lesser pressure. But if a area is less, all overall the force applying on the pressure, applying on the weight will come and will combine on this place, and this how the pressure will be more. There will be much more pressure as all of the body's pressure is applying on a little area. Here the more area, that's why it's having a less pain, it's having more pain. Understand? Because more pressure is applying, that's why. Now we need to understand that what is pressure actually. Okay, writing the proper definition of pressure is pressure is a force or is an exerted force per unit area. This we can represent by the formula pressure, as P is the symbol of pressure, force upon area. This is the formula you need to memorize. This will always help you in finding the pressure in only solids. Remember, this is the lesson of pressure in solids. I'm not talking about the liquid or gas. In solid, you need this formula to identify what is the pressure of the area. Okay, now moving towards another area. What is the SI unit of pressure? Pressure is always measured in pascals. Remember, if you will not put amount or the answer with the SI unit, the 1 mark will be deducted. So Pascal, the SI unit is important to put up. Okay, now we'll take some example to understand more further. First, we need to understand the pressures questions. First, we understand some more concepts like why is we are identifying the force and area. Why is it important to understand about the force and area in pressure, which is related to question number 1? This we can understand. This is the area. Surface. It is an object on a surface, so we need to identify that what is the area and the exerted force on it. Force per unit area. How the area on which the force is applied is known as pressure. It's the simple formula. Now the most important question is in front of you, which is differentiate between force and pressure. What is the difference between force and pressure? We need to understand this briefly in physics. It's not a simple question which is coming in the exams, but you have to understand the concepts which is needed to be clear. This is an object on the surface. It is also an object on a surface. Now for example, I am also applying the pressure on it and I am applying the force on it. Obviously it will move forward. Not in the case of pressure somehow, as for example we'll take the example of wall. So at the wall it will not move forward while I'll apply the pressure on it. But yeah, at the force it will move forward. We need to not understand about this. The main difference is that at the force we are not supposed to understand the area of and on an object. If I am applying the force, it is not necessary to identify or to determine the area of an object. That force is not asking about the area. Yeah, but we in the pressure can understand that area is necessary to be understand. Here we took some important examples. That's why we are supposed to write pressure is equals to force upon area. This is the only difference between force and pressure, that in force we are applying the force on an object which are moving anywhere. It is not important to identify the area, but for area in pressure is important to understand, otherwise we cannot take out the pressure. As in the mathematical formula it is included. Area of an object is most important in pressure. You need to remember and memorize it for your physics assessment. Now moving ahead and identifying the answers of the questions. How pressure is directly proportional to force and pressure is inversely proportional to area. You need to understand that these questions are not coming in CI, but we need to understand the concept, otherwise the question will be not easy for you. Okay, now we'll take an example. For example, we are keeping 1 meter square is your area, and we are taking the force as 50 newtons. Okay, now we'll multiply it. We'll divide it. In pressure, force is dividing by area. Force never multiply, it divides by area. So we'll put the values now. 50 upon 1 is equals to 50. Do you think something is missing? Exactly. Pascal, the SI unit. If I'll not put Pascal, what will happen? Obviously the mark will be deducted. Pascal is the unit which is important, and this is your answer. Okay, we have took 1 meter. Again, it would be an area. Obviously meter square is representing the area, and we'll take the force as 30 Newton. Okay, now putting the formula. Remember that writing the formula in paper will give you 1 mark. Writing the formula is important. Force divided by area will be 30 pascals. Now you're observing something here? Yes, we have kept the area same. The value of area is same, but the value of force is different. It means when the force is decreased, so the pressure is decreased. As the pressure will increase, force will increase. When the pressure will decrease, force will decrease. Force is increasing 50, so Pascal is 50. When the force decreases but the area is the same, now the pressure will decrease. Now we'll take an example that if we are also changing the area, what will happen? Okay, now come on. For example, we are taking 1 meter square and 50 Newton, the same as the force and the area. Putting up the value. Yep. Okay. Alright. So it's the same as above, you need to remember. And if we are changing the area, like for example, I'm putting 4 meters square. And the force will be same, remember. So now we have to calculate it. 50 upon 4. Alright. So I hope so that you will understand. 50 divided by 4. Okay, so the answer will be 12.5 pascals. Here you can easily see that the pressure is decreased. Because the area is increased, now the pressure is decreased. This is because if you are having a huge body and having a simple body, so at this peak, we can understand now that here the area is lesser and here is a huge area. So as the body is having its weight, here the body's height, or we can say as the weight is more, weight is distributed in many parts. You are understanding that these are the force which are distributing in many parts. That's why each of the area is consuming the force. That's why the pressure is here more. Sorry, the pressure is here less. At this area, there will be more pressure because of overall the body's weight is applying on a single part, because whole of the body's weight is applying on the single part. That's why the pressure here will be more and here will be less. As we are extending the area, force will be less. If we are decreasing the area, there will be more pressure. You need to understand this concept to identify and understand the questions to be answered the question. Now we are here to understand about the pressure in liquids. What does it mean by the pressure in liquids? For here you need to not remember the force or area. This is only given for the pressure in solid. For the pressure in liquid, another thing is explained. Liquid's pressure depends on three things. First is the liquid, liquid's height or depth, which is represented in h. Remember, h represents height or depth. You know that h represents height in maths. Liquid's height represents by h. Okay. Another on which the liquid's pressure depends is the most famous gravitational field strength. In CI, mostly the gravitational field strength is having 9.8 or 10th value. In CI, 9.8 is not allowed as they has tell us about 10th, so we have to consider is what CI has tell us. The third is density, which will represent in rho. This is called rho. Okay, so liquid's pressure depend on liquid's height or depth. It means, for example, we have filled up the water. Okay, so what is the density? Which you need to answer for finding the pressure. Gravitational field strength, obviously. And the liquid's height, or how much is it on the depth. This is of the liquid's pressure you need to understand. So you need to understand about the gravity, which is 10th, height of the liquid, because obviously when liquid is having its own area, its own density, so it's also applying the force. It is also receiving the force from earth, which is known as a gravitational field strength, which is given 10th in your CI. So as the symbol of density is rho, gravitational field strength is g, liquid's height or depth is h. So this how we can create the formula of pressure in liquid is rho g h. Obviously these will be multiplied by themselves to find the pressure. Now the questions for pressure in liquid will come like as they will give you the value of rho and height, and obviously the gravitational field strength value is 10, so it is acknowledged by yourself. So it will not give in the question, however I think so that it will be given the question. You need to understand that gravitational field strength value is always 10. They will ask from you to answer the pressure in liquids, what is the pressure of the liquids, and you have to apply this formula, which is very important, the mathematical formula. However, they will also can reduce one value. For example, they can reduce the value of density. So you need to identify firstly to find out mass multiplied by volume. To answer it in the question, as it's asked about you to ask to find out the value, so these can be types of questions that it is not important that they will give you the valency of density too. You need to understand the formula, you need to memorize it, otherwise the paper is hard for you. One more thing which you need to understand to clarify your concept is, for example, I'm having this type of ball, whatever you want to say it, having the passing of water from three sides. So from this the water will be passed like this. Okay, from here the water will be passed like this, and from here the water will be passed like this. So this is known as depth 1, this is known as depth 2, and this this is known as depth 3. Now what you are seeing the difference between these three types of depth? Exactly. If there will be lesser depth, so the pressure will be less. Here is the less pressure, and here is the more pressure. As the water is and the depth, if the depth is high, so the pressure will be more. If the depth is low, the pressure will be less. So we can understand that pressure in liquid is directly proportional to depth. If there will be more depth, there will be more pressure. If there is less depth of the water, of the liquid, there will be less pressure. You need to memorize this all. What is the figure telling about you will become in exam too. So I hope so that you understand the video. If you have some typical confusions, so just comment below and you just wait for the reply. Thanks for watching.